So now let's start on descriptive statistics. And this is our last topic. So this topic is somehow wide, but I just want only to focus on the most important things of this topic, which are the one which are highly examinable. Yeah, so now let's discuss what we have. I'll only be doing computation. Most of the theory I will just be discussing them. So that's why I requested that you have the notes in advance. So what do we mean by descriptive statistics? Now, this is a brief descriptive that summarizes a given data set. It's all about a summary of a given data, which can either be a representation of the entire population or a sample of a population. Yeah, mostly for descriptive statistics, it's done where you have gathered some information. Now you want to summarize this information. So how do you summarize? Now that summarization of the data is what we call the descriptive statistic, taking the important information from the entire population. Now, the major importance is to produce a brief summary of the sample and measurement and measures done on particular study. So what are some of the elements? So elements of descriptive statistics. Yeah, and those elements now will form the subtopics of this descriptive statistic topic. One is the measure of central tendency. And then number two, we have the measure of dispersion. Number three, you also have the measure of skewness. Then number four, we have measure of kurtosis. Yeah, those are the 5 elements of descriptive statistics. Now let's start with the first one, which is the measure of central tendency. So in this case, we are not copying it. You already have the notes. But just want to we just study what we have, discuss what we have. Now, what do you mean by measure of central tendency? Now, these are the values computed to show the central or the center of a particular set of data. Yeah, and for the measures of central tendencies, they are major classified into 3. One is on how do we compute the mean. It's all about the determination of the mean of the average. Then, once you get the mean, you also need to determine the median. Once you determine the median, you also need to determine the mode. So that's what comprises the measure of central tendencies. Now, these are values computed to show the centers of a particular set of data. So what are some of the characteristics of these, mean, median, and mode? Number one, it's based on all the values of the data. So for example, for you to get the mean, you have to add all the values, then you divide by the total number. Yeah, that means is one of the characteristics that is based on all the values of the data. Then number two, rigidity defined. Come to explain that. Also, it's not affected by the short-term fluctuations. Also, it's easy to compute and understand. Yeah, that's another characteristic. Another characteristic of measure of central tendency, it should be number one, easy to compute because you already have all the data. Then it's not affected by the extreme values. Yeah, whenever there is that big variation or big margins, it will not affect our data. And they are subdivided as follows. Number one, we have the mean, we have the median, and then we have the mode. Let's start with the mean. What do we mean by mean? Mean means the average. Yeah. So this is the average of a set of data. Can you underline the average? Underline the word average. Yeah, this is the average of a set of data. Yeah, they are subdivided as follows. Also for the mean, they are classified into 3. One, we have what we call the arithmetic mean, or what we call the sample mean, or the simple mean. Yeah, simple mean is all about taking the total divided by the total number of items. Then number 2, we have what we call geometric. Geometric mean, and then we have what we call harmonic mean. Yeah, the means are classified into three. We have the arithmetic mean, we have the geometric mean, and then we have the harmonic mean. Let's start with the first one, the arithmetic mean. Now, this is obtained by dividing the sum of the values using the number of values. Yeah, that's what we call the arithmetic mean. Or the simple mean. They're saying that it's all about taking the total, then you divide by the number of items. So this is obtained by dividing the sum of the value using the number of value, That means to get the mean, a demonstrated mean is denoted by X bar. Whenever you see the X bar, that represents the mean. So you'll take the sum of the values, you divide by the number of values. Number of values. That means is a summation of X, then you divide by F. Yeah. So when the data is grouped, in case of a grouped data, I don't know what's a grouped data. For example, if you are given the number of students who scored between 10 to 20 marks, there were 15 students. Who scored between 20 to 30, there were maybe 12 students. Who scored between that to 40, there were 20 students. Now, this is what we call a group data. Now, in case of a group data, and we want to determine the average. So how do we get the average for the group data? So in this case, you take EFX, where F is the frequency, X is the number, you divide by summation of F. They're saying that F means the frequency. For example, in this case, the number of students would be our F, the frequency. Then X is the number of marks. But you see, in this case, we're given the group data. For example, in this case, 10 and 20. How can you get the average? So you just compute what you call the midpoint. Or those students who scored between 10 to 20. So to get the midpoint, you just take 10 plus 20, you get 30, and then you divide by 2. So your X will be 15 here. Here will be 20 plus 30, you get 50. 50 divided by 2, 25, like that. Yeah, so that's our X. F is the frequency, X is the number, depending on what you're investigating. Yeah, that's all about the arithmetic mean. Then number B, we have geometric mean. I want first of all, we discuss all of them before we do some illustration. So how do you get geometric? Now, this is the nth root of n value in a set of data, and it's computed as follows. Yeah, geometric mean is all about determining the nth root. And how to determine the geometric mean? Now, to determine the geometric mean, you'll take the nth root, then you take the values. For example, x1, you multiply by x2, you multiply by x3, blah, blah, you multiply by xn, all the value, and then you get the nth root. Now the question is, how do we get the nth root? So I've given an example there. So you are told that compute a geometric mean for 1, 3, 4, 6. How do we get the geometric mean of 1, 3, 4, 6, 8? You just multiply them, and then you get the nth root. How many values do we have? 1, 2, 3, 4, 5. So you compute the fifth root. So how do we get the fifth root? So first of all, can you multiply this? Multiply all this. 1 times 3 times 4 times 6 times 8. You get 576. Now, once you get 576, now how do we get the fifth root? Now, to get the fifth root, you get 576. Now, to get the fifth root, you press 5, shift, raised to power, shift, raised to power. Then answer, press answer, then equals. What do you get? 3.56. That's how we get the nth root. So can you compute for me 6th root of 100? compute for me the sixth root of 100. So to get the sixth root of 100, you press 6, shift, raised to power. And then 100 equals. What do you get? Sorry? 2.15. Also now, compute for me fourth root of 20. Give me the fourth root of 20. Yeah, you press 4, shift, raised to power. Alternatively, sixth root of 100 is the same as doing this. Is the same as 100 raised to power 1/6. So what does it mean? Can you press 100? Raised to power, open the bracket. First of all, you have to open the bracket. You open the bracket, 1 divided by 6. You close the bracket. So that means also to get the fourth root of 20 is the same as taking 20 raised to power 1/4. Now note that that's why you always aggregate the use of body mass. If you take 20 raised to power 1/4, the calculator will give you 20 times 4. Because if you take 20 raised to power 1, then you divide by 4. This is how it will interpret. It's 20 raised to power 1, which is 20, and then it divides by 4. So that's why it will give you a wrong answer. So you have to take 20 raised to power, you open the bracket, 1 divided by 4. Good. So now you know how to compute the nth root of a given figure. Good. Right. Then that was for geometric mean. Now, in case the data is grouped, for grouped data, this was for ungrouped data. Ungrouped data. What of the grouped data? How do we get the geometric mean? Now, to get the geometric mean for grouped data, you take the antilog of, you take summation of f log x divided by summation of f. Yeah. So you take the antilog of, you take the summation of f, we see that f is the frequency, log x, you divide by the summation of the frequency. Good, so we can do that illustration. I've provided you an illustration there. Illustration 1 on how to get the geometric mean for group data. So you're told that compute the geometric mean of the following data. So you have the marks and then we have the student. So we have the marks. Now marks represent x and then the number of students. That one will give us the frequency. So marks we had that. We had 50, 80, 90. And then we have the number of students. So you have 5, 20, 5, and 2. Now, number 1, when determining anything under descriptive statistic, first of all, read what is required. So for example, in this case, the question is compute the geometric mean. So in that case, in case of a geometric mean, so how do you determine that? So you need summation of f. F is the frequency. So can you add the total frequency? That is that. That too. You also need f log x. So how do we get that? F log x. So for example, in this case, f is 5. Can you press 5? Then log. Our x is 30. Press 30. Equals. What do you get? You get 7 point into 2 decimal places. So in two, sorry? 38. 38. We do the second one. F. So the formula is f log x. So you take 20 log 50. You get? That 3.98. 5 log 80. 9.52. 2 log 90. 3.91. So now let's add the total, because here we need the summation of f log x. You get 54.79. So therefore, to get the geometric mean, you say that you will take the antilog of this is the formula. Summation of fx, this is the summation of fx, which is 54.79, divided by summation of the frequency. And our summation of frequency we have is that too. So do this. You take 54.79, you divide by that too, equals. Then you get the antilog. So to get the antilog, you press Shift, log, then answer equals. Shift log, so that's what we mean by antilog. Answer of the answer, then equals. So what do you get? 50? 51.55. That's how you determine the geometric mean. So you have looked at arithmetic mean, that's a simple mean of the normal mean. We have also looked at the geometric mean. Then lastly, another type of mean, you see that means are classified into 3. Then we have harmonic mean. Harmonic mean, that's HM. So what is harmonic mean? Now, this is the mean of the reciprocal of all the values of the set of the data. And it's computed as follows. So how do you determine the harmonic mean? So to get the harmonic mean, it depends whether the data is grouped or ungrouped. So in case of ungrouped, you just take n, that's the total number, summation of 1 over x. This is in case of ungrouped data. Now, in case the data is grouped, to get the harmonic mean, you'll take summation of frequency, 1 over x. And this is a case of the grouped data. We shall do an illustration on that later. So now here you need to understand, apart from cramming the formula, because some students, they don't understand the formula. They only cram the formula. Apart from cramming the formula, you need to also to know what do they mean and how do I apply. Because you can know the formula, but now you don't know what is f. You don't know what is x. Yeah, so that's all about the mean. Number 2, there was the median. We're looking at the measure of central tendencies. So that there is mean, median, and the mode. What do you mean by median? Median, katikati. Yeah. Average, okay, mean is the average. Median is the middle point. Mode, it's all about the number with the highest frequency. The one has been repeated twice. So now let's look at median. What do you mean by median? Now, this is the value which subdivides the data into 2 equal parts. Can you understand that? Which divides the data into 2. Divides the data into 2. So that's why it's called the median. So when the data is ungrouped and the number of items is even, this is what I mean. For example, we have 4, 3, 6, 2, 4. Now, in this case, we want to determine the median. 1, 2, 3, 4, 5. The median is the one iko katikati. In this case, it will be 6. But you see that when the data is ungrouped and the number of items is even, what does it mean? Now, here we have 4, 3, 6, 2. What is the median? You see, in this case is 2, 2, but in this case, they are 4. That's why you're saying that. That's I have written that point that when the data is ungrouped and the number of items is even, median is the average of the two values which are at the center. So in this case, the two values at the center are 3 and 6. Whatever, you get the average of the two, and that's how you get the median. Yeah. If number are even, saying that the median is the average of the two values which are at the center. And how do we determine the median? Now, to determine the median, you take the row boundary of the median class, then you add n over 2 minus the cumulative frequency, you multiply by the width, all of it you divide by the frequency, where what is L, what is N, what is CF, what is W. Now, L is the lower boundary of the median class. The lower boundary of the median class. Then, what is N? N means the number, yeah, or the sum of frequency. Sum of frequency. Yeah, if you add all the frequency, you get the total number of items at the investigation. So that's our N. Then we have CF, this is the cumulative frequency of the median class. Yeah, cumulative frequency of the class above the median class. I want you to underline that. Can you underline that? Underline that in your notes. Yeah, that CF is the cumulative frequency of the class above. This is what I want you to underline. Of the class above the median class. Yeah, the class above the median class. And then we have F. You see that F is the frequency. Then W is the width of the median class. The width of the median class. That mostly is for the grouped data. And then lastly, let's look at mode. Mode. Yeah, mode represents the number which has the most frequencies, or which has the highest population. And what do you mean by mode? This is the value that has occurred the highest number of times in a set of data. Can you understand that? The highest number of times in a set of data. Yeah, that's why you have to have the interest. Now, for example, if you give the student a cat, yeah, majority of them, they scored between how much? Now, where you have where majority of the students scored that value, that's what will give us the mode graph. Now, when the data is ungrouped, mode is identified by inspection. You just inspect. And when the data is grouped, the mode can be obtained using a histogram or a formula. And how do we determine the mode? This is how you determine the mode. Now, mode, you take L plus F2, F1 plus F2, all of it you divide by the width, where what is L, what is F1, what is F2. So we know what is W. Now, L is the lower boundary of the model class. Lower boundary of the model class. But tumesema model class, this is where the number has the highest value of occurrence. Then we have F1, is the frequency of the class above model class. F2 is the frequency of the class below the model class. W is the width of the model class. That's what we need to differentiate between the two. That F1, saying that is the frequency of the class above. F2, the frequency of the model class below. And then width is the width of the model class. L is the lower boundary of the model class. But for median, you see, both of the formula, they have L. L is the lower boundary of the median class. When you're computing the mode, will be the lower boundary of the model class. So, and the median is the one which is on the average, katikati. Mode, which has a lot of repetition, we have the highest number. So that's the one of the best way of differentiating between the median and the mode. Good. So I think with that now we can do some illustration from our past paper. Do an illustration from the past paper. So open with me, April 2022. April 2022, question 2B. So question 2, let's start with part A of the question. We'll have to discuss, we'll come to discuss that later. Explain 3 types of kurtosis that a graph representation of the frequency distribution can assume. 6 marks. And there are 3 types of kurtosis. We'll come to discuss that later. Now let's first of all do part B. The following data shows the age distribution of 350 employees of a multinational company. So you have the age in years, the number of years. Required. Compute the following measure and give an interpretation of each. Number 1 is the mean age. Number 2 is the median age. Number 3 is the standard deviation. Number 4 is Carl Pearson's. So first of all, I want us to do the mean, the median, and the mode using that illustration. We'll come later to discuss about the measure of dispersion. That's why we compute about the standard deviation, coefficient of variation. So how do we use that information? So number 1, we have the age in years between 20 to 25, 25 to 30, 35, sorry, 30 to 35, 35 to 40, 45, sorry, 40 to 45, 50, sorry, 45 to 50, 50 to 55, 55 to 60, and 60 to 65. Now, how do we get X? Now, to get X, you determine what to call the midpoint. Now, that will be our X. Now, reason up here. Now, to get the midpoint, you take the summation of the age divided by 2. For example, this one will take 20 plus 25, you get 45. 45 divided by 2, you get 22.5. 25 plus that, you get 55. 55 divided by 2, you get 27.5. This one will be that 2.5, that 7.5. 42.5, 47.5, 52.5, 57.5, and then you have 62.5. Now that will be your midpoint. Then you already have the number of employees. The number of employees will give us the frequency. Number of employees. That's your F now. So here we have 20 employees. Yeah, in short, that means 20 employees, the age is between 20 to 25. Then we have 70, 100, 65, 40, 25, 15, 10, and 5. Now, can you add how much is the total number of employees? Already given the question. Can you read the question again? The following data shows the age distribution of 350 employees. So the summation of the frequency, they are 350. If you add this, you should get 350. Good. Now, with that, we need to compute mode. So first of all, we have to compute the mean. Once we compute the mean, we also need to compute the median. Also, we use the same information to get the mode. So to get the median, you need, number one, cumulative frequency. Number one, you need the cumulative frequency. Now, these are our frequency. 20 employee plus 70, you get 90. 90 plus 100, you get 190. 190 plus 65, you get 255. 255 plus 40, you get 295. 295 plus 25, you get 320. 320 plus 15, you get 335. 335 plus 10, you get 345. 345 plus 5, you get 350. We also need fx. We also need fx. That one will help us to determine the mean. So fx, we have f, we have x. 22.5 times 20, that's 225 times 2, you get, is that 550? Sorry, 450, eh? So you get 450. 70 times 27.5. 1925. Yeah, you get that 250. 65 times that 7.5. 24. That's 7.5. 42.5 times 40. Sorry? 1700. 47.5 times 25. 1187.5. 52.5 times 15. 780. 787.5. This one will be 575. 62.5 times 5. Sorry? 312.5. Now, can you add for me the total? Add for me the total, so that we get the summation of fx. You get 12? Now let's go to the required. Required. Number one. And number one, you have to compute the mean age. So how do we get the mean? Mean is our x bar. We see that to get the x bar, you take summation of fx, you divide by summation of frequency. That was the formula in case of a group data. So summation of fx we have is 12,625. You divide by the summation of the frequency. The total number of employees was 350. So what's the average age? Sorry? Point? Good. So it will be that 6.07. So that's the mean age. Yeah, most of the employees is 36.07 years. Number two. So I want us to compute both median, even the mode. So let's compute the median. So that to get the median, you'll take the lower boundary, n/2 minus the cumulative frequency. You divide by, you multiply by W over F. So now let's adopt this. We said that when you're determining the median, what is L? L is the lower boundary of the median class, a median katikati. Now, if you look at this age bracket, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9. So what's the median? Median. It's 1, 2, 3, 4 from above, 1, 2, 3, 4 from below. So this is where we have our median, katikati, between 40 to 45. That's why you have the median class. So now we need to determine L is the lower boundary of the median class. This is our median class between 40 to 45. So the lower boundary is 40 years. The upper boundary is 45. So here we need L. The lower boundary will be 40 plus, now you get this average. And we see that our N is the sum of frequency, of which we have 350 employees. You divide by 2 to get the average. Then you minus the cumulative frequency. What is this? Let's be here. There is something I told you to unwrite. Cumulative frequency at CF is the cumulative frequency of the class above the median class. Cumulative frequency is the cumulative frequency 1, 2, 3, 4, 5 here of the class above. This is the class above. This is the class below. So cumulative frequency, or CF, is the cumulative frequency of the class above the median class. Now, cumulative frequency of the median class is 295. So therefore, our CF will be the class above, which is 255. So you minus 255. All of it you divide by F. What is F? F, you see that is the frequency of the median class. How much was the frequency of the median class? The frequency of the median class, they were 40 employees. So you divide by 40, though here, you have to, you multiply by width. See that W is the width of the median class. This is how you get the width. Between 40 to 45. So what's the difference of the age? The difference in age is how many years? 5. And you compute that. Then you use body mass. This is how you use the body mass. 350 divided by 2, give me that. Then you minus 255 equals. Then you multiply by 5 equals. Then you divide by 40 equals. Now what you get, now that's when you add 40. So you add 40, you get an amount of that. Yeah, the median class will be that. Good. Lastly, let's compute the model. Model class. So how do we get the model class? To get the model class or the mode, it's lower boundary plus F2, F1 plus F2, all of it you multiply by the width. So it will be, what is F2? All right, let's be here. Or first of all, let's start with L. L for model class is the lower boundary of the model class. Now, model class, you look at the frequency. See that mode, this is where you have the highest number of occurrences. Okay? So in short, which age bracket has the highest number of employees? That's where you have the mode. Just look at the age bracket, you look at the number of employees. These are frequency. Which age bracket has the highest number of employees? Yes, that is that right. In short, our mode is 100. So that means the age bracket where you have a lot of number of employees where you have 30 and 95. So to get L, you see that is the lower boundary of the model class. So the model class is between 30 years to 35. So the lower boundary will be 30 years. So you take 30 plus F2, F1 above, F2 below. That's what you just need to master. That F1 is the frequency of the class above. F2 is the frequency of the class below the model class. This is why you have the model class. Now, F1 is the one above, which is 70. F2 is the one which is below. So F2 is what we need, which is below. So in this case, the frequency of the model of the class below is 65. You divide by F1. F1 is the one which is above the model class frequency, which is 70. plus F2. Our F2, we already have it 65. All of it you multiply by the width. The width of the median class between that to that 5 years, the difference is 5 years. That's what we call the width. So you apply the bracket, use the board mass, you take 65, or first of all, you take 70 plus 65. Then you take 65, divide by the answer. Then what you get, you multiply by 5, and then you add that. You get that 2.4 codes. That's 2.4. That's 2.4. As simple as that. So you can take a small break. Then we come, we do other measures. Only for 3 minutes. Take a break of 3 minutes, then we come back. So now let's do another illustration on harmonic mean. So that was on the normal mean or arithmetic mean. So in case now I have to compute on harmonic mean, I will do that illustration in our notes. So harmonic mean, we see that. How do we get the harmonic mean? In case of a group data, we see that in case of a group data, to get the harmonic mean, you take the summation of frequency, then you divide by summation of frequency 1 over x. That's how you get the harmonic mean. Now let's do that illustration. Now the following data shows the distribution of daily wages in a certain company. So they are doing their own distribution. We have the wages and then the number of workers. So we'll have the wages. So between 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. That's the wages. So first of all, once you are given the group data, you have to determine X. Now, X will be the midpoint. So you compute the midpoint. That will be now our X. So between 40 to 50, so you take 40 plus 50, you get 90. Then you divide by 2. 90 divided by 2 is 45 shillings. 50 and 60 is 110. 110 divided by 2, you get 55, 65, 75, 85, 95. Then we have the frequency. Now, frequency is the number of employees or number of workers. Now, that one will give us our F, the frequency. For those who earn on average of 45 shillings per day, there are 20. There you have 25. We have 36, 72, 51 workers, and 40. Now, give me the total number of workers. This company has how many workers? You get 244. 244. I told you that the important thing, first of all, read what is required. Now, if we need harmonic mean, do you know the formula of harmonic mean? First of all, write the formula. Now, this is the formula for harmonic mean. We need summation of frequency. We already have that. We also need summation of frequency 1 over x. So we need to compute frequency 1 over x. Now, frequency 1 over x is equivalent to f over x. As simple as that. So let's do that. F divided by x. We already have f. We have our x. So for example, the first one will be 20 divided by 45. What do you get? 0.44. 25 divided by 55. 0.44. 45. That's 6 over 65. 0.55. So this one will get 0.96. This one will be 0.6. This one will get 0.42. And then you add the total. Give me the total. You get? Get 3.42. So therefore, to get the harmonic mean, we see that is a summation of frequency, summation of f 1 over x. So it will be summation of frequency we have is 244 divided by summation of frequency 1 over x, which is 3.42. So on average, you get how much? 71.35. Good. was that? So that was the measure of central tendencies. You see that we see that descriptive statistics have 4 elements. One was the measure of central tendency. Number 2 was the measurement or measure of dispersion, measure of skewness, and measure of kurtosis. Now let's look at now measure of dispersion. Yeah, that's how we get the standard deviation, the variance, all that. Measure of dispersion. So we are done with the measure of central tendencies. Yeah, that one mainly covers the mean, mode, and median. And then for the mean, we have said that we have 3 types of mean. We have arithmetic mean, called simple mean, geometric mean, and harmonic mean. So make sure you know the formulas on how to determine those 3. Now let's now determine number 2, measure of dispersion. Of dispersion. That's our second element of this topic. And these are used to determine how far a particular value is from the central value. It's all about the variation. Yeah, this is used to determine how far a particular value is from the central value. Yeah, so the difference between the two is what we call the range. So therefore, how do we get the range? Now, the range is the difference between the maximum value and the minimum value. That's how we get the range. It's the difference between the maximum and the least value. And then how do we get the variance? So first of all, let me explain. Standard deviation and how to get the variance. Now, in case of ungrouped data, yeah, I remember doing this when we were doing decision making, yeah, on how to measure risk. You see that risk can be measured using either the standard deviation of the variance. You take x minus x bar. If you have the probability, you square times probability summation square root of n. This is when there is probability in the presence of probability. If there is no probability, it will be x bar is our average, square all of it, n minus 1. And then, yeah, that's the summation. And then you get the square root. So this one is in absence of probability. So to get the variance, now variance, you take the standard deviation square. The standard deviation is noted by that. So to get the variance, you square. Or alternatively, use the same formula, but you don't get the square root. That's the difference between a standard deviation and a variance. So to get the variance, you square the standard deviation. To get the standard deviation, you get the square root of the variance. That's the difference between the two. Yeah, then I have given some formula there on how to get the quantile ranges, all that. So now, in case of a grouped data, case of grouped data, so how do you determine the variance or the standard deviation? Now, to determine the variance, you'll take the summation of fx squared, you divide by the summation of frequency, then you deduct summation of fx divided by summation of f, then all of it you square. Right. That formula should be at your fingertips because this is one of the common questions. Therefore, to get the standard deviation, you'll take now the square root of the variance. Yeah, that's the difference between a variance and a standard deviation. So to get the variance, this is the formula. And then to get the standard deviation, in case of a group data, you get the square root of the variance. Then how do we get the coefficient of variation? Coefficient of variation. Now, to determine the coefficient of variation, you'll take the standard deviation. That is how the standard deviation is noted. This is how the variance is noted. Standard deviation, variance. So to get the coefficient of variation is a trade-off between the risk and the average. So the standard deviation and the average. So here you divide by X bar, and then you can multiply by 100%, where X bar is our mean. And this is the standard deviation. Standard deviation. So you can look at that formula for 1 minute before we do an illustration. So I want us to do an illustration. So open with me December 2021, question 2. December 2021, question 2. And we have 2 Decembers. One was the pilot paper, the other one was the real paper. So I'm talking about the real paper, not the pilot paper. Question 2, I told that. State 5 advantages of arithmetic mean as a measure of central tendencies. One of the advantages. Eh? And we looked at the characteristics. Most of their characteristics are some of the advantages. We see that number 1, it's easy to calculate since the data is readily available. Can you go back to your notes? I've given the solution there. So advantages. 1 is easy and fast to calculate. It's already in your notes, the solution. Number 2, it's easy to work with and use the in further analysis. It's also, its rigidity defined. It is least affected by the fluctuation in sampling. Yeah, those small changes does not affect our outcome. Then it also takes into account all the values in the series. And those are some of the advantages of arithmetic mean. Number B of the question, number B. The following data shows the distribution of profit of 150 manufacturing companies in a year. So that means 150 is our N, or the summation of frequency. The total number of companies was 150. So we conducted a research on 150 about their profits. So we have the profit, we have the number of companies. Required, number 1, the arithmetic mean of the profit and interpret the results. Number 2, standard deviation of the profit. Then number 3, the coefficient of variation. Yeah, a total of 20 marks. So how do we get that? So first of all, you need arithmetic mean. You need to know the formula of getting the arithmetic mean. You also need standard deviation. You also need to have the formula on how to get the standard deviation, as well as the coefficient of variation. Now, coefficient of variation, you need the arithmetic mean. You also need standard deviation. So how do you work with that? So first of all, you have the profit. That's our interest. So between 10 to 20 million, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Then we determine the average. That's our midpoint. Now, our midpoint will be our x. So 10 to 20, that is 30. 30 divided by 2, you get 15. 20 plus 30, you get 50. 50 divided by 2, you get 25. This one will be 35, 45, 55, 65, 75, 85, 95. Then we have the number of companies. Now, the number of the companies is our F, the frequency. So how many companies are making an average of 15 million? So we have 15 companies. Then we had 13 companies. We had 25, 30, 16, 10, 22, 12, and 7. Can you add the total frequency? Did you get the number of company which was 150? Just add that. You get 150, which was the number of companies. Then we also need fx. Also, to get the standard deviation, there is a formula where we need summation of fx squared. Yeah, I told you the formula is very important because the formula will give you what you need now to compute. So now let's start with fx. We already have x, we have f. 15 times 15, you get 225. 25 times 30, you get 325. That 5 times 25. That 5 times 25, you get how much? 875. 450 times 30, get 1350. 55 times 16, 880. This will be 650. 75 times 22, 1650. 85 times 12, you get 1020. 95 times 7, 665. Now, can you add for me the total? Because we need the summation of fx. You get 76, 40. We also need fx squared. Fx squared. This is fx. This is not what we need. What we need is f times x squared. So for example, in this case, you'll take, first of all, get x squared, which is 15 squared, then times f, which is 15. What do you get? You get? That 375. I repeat again. Fx squared, it's not this. Now, if you wanted fx squared, this one, it could be summation of fx squared. That's when you take this squared. But what you need here is f, you multiply by x squared. So first of all, you have to get your x squared. So this will be 25 squared. Then you multiply by f. So what do you get? The second one? 81. This one will get 8125. This one will be 3625. You get 16,750, 48,400, 42,250, 123,750, 86,700. Then we have 63,175. Then you also need the summation. So summation will be 467,150. So now we have all the ingredients required to determine or to answer what was required now. Now let's go to the required. Number one, we are to determine the arithmetic mean. So how do we get the mean? Mean is our x bar. See that to get x bar, you take summation of fx over summation of f. We have summation of fx, which is 7640. You divide by summation of f. They were 150 companies. So what do you get? 50.9, eh? So how do we interpret that? You see, in this case, we are conducting research based on the company's profitability of manufacturing industry of 150. And then our profit were given in millions. So that means on average of that industry of manufacturing, on average, they make a profit of 50.93 million. That's how we interpret that. Based on your research, most of the company in that manufacturing industry, they make an average of 50.93 million per annum. Number two of the question. Number two, we have to compute what? The standard deviation. So how do we get the standard deviation? How do we get the standard deviation? So to get the standard deviation, which is denoted by that, you compute the variance and then you get the square root of the variance. So how do we get the variance? So first of all, we get the variance, which is standard deviation square. Say that to get the variance, it will be, I gave you the formula, the summation of fx square, you divide by summation of frequency minus summation of fx over summation of f, then you square. That's how we get the variance. So first of all, we compute the variance. Summation of fx squared. Here is our fx squared. The summation is 467,150. You divide by the summation of frequency. There were 50 companies. Then we minus. Now this is mean. In short, this is mean. Eh? Now if you look at this, can you let's begin? Summation of fx, summation of f, that's our mean. And then you square. So as simple as that. So it will be summation of fx, which is 7640. Summation of f, which was 150. You get the mean. And then you square. What do you get? You get? Don't get the square root. First of all, I want the variance. Just square your answer. You go back to the variance. How much was the variance? 520 point? Yes? 2.9 million. Now that was the variance. But what you need is the standard deviation. So to get the standard deviation, you get the square root of the variance. So now you get the square root of 520.29. So square root of the answer? 22.81. Then number three, you have to get the coefficient of variation. Now, coefficient of variation is a trade-off. You see, now let me explain something here. In this case, we're evaluating about the profits of the company. Standard deviation is the measure of risk. Mean is the average profit. So therefore, CV is a trade-off between the risk you are taking for to generate 1 unit of profit. So therefore, we take the standard deviation, you divide by X bar times 100%. So standard deviation we have is 22.81. You divide by average. So that's our mean. Our average profit is 50.93 times 100. You can express it in percentage. You get? 44.7%. Now let me interpret. What does it mean? Now, CV, it shows the amount of risk taken for you to generate 1 unit of return. So that means for this company to generate 1 unit of return, they are taking a risk of 44.7%. Yeah, for this company to generate 1 unit of return, the risk they are taking is 42.7%. Good. So I want you to go and try this question. We had done earlier, the one for August. Was it August? No, it was April. April 2022. Yeah, it was question number 2B. Let's go back to that question. Go back to that question. Open that question. April 2022, question 2B. Yeah, 2B required was you compute the following measures and give the interpretation of each. We computed the mean, we also computed the median and the mode. So it's a question we did. Then number 3, it wanted the standard deviation of the employee. So I want you to use that question now for revision purposes. You do that question, then you compute number 1, the mean. We have already computed the mean. You also compute the standard deviation. You also compute CV for you to understand. Also, you can go and try this question. Also, you can go and try. August 2022. August 2022. Question 6B. August 2022. Question 6C. 6C. Open that question. Just open that question. So you're told that the data below shows the probability distribution of profits earned by a firm in a manufacturing industry. So we have the profits, we have the probability. Now in this case, there is no frequency. In this case, you're given the probability. So number 1, you'll get the expected profit. So how do we get the expected profit? Now, expected profit is the same as profit, the mean. So to get the expected profit is our X bar, which is the same as EMV. So you'll take the profits, the way you are given this, then you compute the midpoint. You compute the midpoint, then you have the probability. So to get the average, for example, let me use this one. The first one, the probability was 0.05, the other one was 0.05, the other one was 0.1. So to get now X bar, or the expected profit, you'll do this. You take the midpoint, 15 times 0.05 plus 25 times 0.05 plus 35 times 0.1. You get EMV. That's step number 1. Then number 2, it's required to get the expected standard deviation. I've given you the formula. To get the standard deviation when you have the probability, you take X, you multiply the X bar. X bar is the mean what you have computed in step number 1. Then you square, you multiply by the profitability, the probability. Then you add all of them, then you get the square root. Now, for example, in this case, this is what you'll do. You take your x's. For example, the first x will be 15. The other one will be 25. The other one will be 35. You minus X bar, what you computed in step number 1. Let's assume it will be 45. You go deducting 45, 45 like that. Then you square. Then you multiply by the probability. Probability of generating 15 in this case was 0.05. The other one was still 0.05. The other one was 0.1. Then you get the answers here. You do like that. Then you add all of them. And that's what you mean by summation. Once you add all of them, that's when now you get the square root. You get the square root of the total. Yeah. If you compute the first one, you compute the square root, that's not correct. So first of all, you have to square times probability, you get the total of them, then you get the square root. And then lastly is the coefficient of variation. Yeah, CV is very simple. You just take the standard deviation, you divide by X bar. In short, you take step number 2, you divide by step number 1. Good. So we can do that. So let's do another illustration in our notes. Let's go back to our notes. Yeah, after April 2022, question 2B, there was another illustration, illustration 3 in your notes. Illustration 3. Yeah, where you have some missing information. You have some missing information. How do we evaluate it? Illustration 3. Now, illustration 3 to that. The table below shows the grouped frequency distribution of marks obtained by 50 candidates in a zonal math contest. So that means the summation of frequency of the total frequency is 50. That's the number of students. So you have the marks, then you have the frequency required. Now, if you look at frequency, between those who scored between 20 to 30, there were 2 students, between that to 45 students, 40 to 50, X, like that. Now the question was required. The value of X and Y, given the mean of the distribution is 61.2 marks, already given the mean. Then number 2, get the variance of the marks. So in case of that scenario, how do you answer that? So we have the marks. We have those who scored between 24 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. So first of all, we get the midpoint. Now the midpoint will be our X. 24 plus that, you get 54. 54 divided by 2, you get? That's 27. 30 plus 40, you get 70. 70 divided by 2, you get 30. 35. 40 plus 50 is 90. 90 divided by 2, you get? 45, 55, 65, 75, 85, 95. Then we have the number of students. That's our frequency. Number of students. Now that will be our F. Those who scored an average of 27, they were 2 students, 5 students. This was unknown. That's our X. 9, unknown, Y. 8, 5, 3. But you know the total is how much? How much was the total? Remember, 50, eh? Yeah, that means, okay, can you add this? 2 plus 5 plus 9 plus 8 plus 5 plus 3. Hiyo ni ngapi? How much is that? Is it that true? But you know that the total number of students were how much? There were how many students? 50. So that means if you take X plus Y, this X plus this Y plus that 2 should give you how much? Give you 50. Another question, we are to get the, first of all, you go to the required. You see, under requirement, it wanted to get the variance. So to get the variance, also you are given the mean. So you need Fx. You need Fx. Then to get the variance, you need Fx squared. So first of all, let's get Fx. Fx, 27 times 2, get 50. 54. That 5 times 5? Sorry? 175. 45 times x? 45x. 55 times 9? Sorry? 495. 65 times y, you'll get 65y. 75 times 8? Sorry? 600. 85 times 5? 425. 95 times 3? 285. Now, can you give me the total? Yeah, add this plus this. You leave this. Also, you leave this for y. Add the others. You get? So this one will be 45x plus 65y plus the other one you're getting how much? 20? 34. Yeah, 20, 34. So now let's get the unknown. So let's be here. Let's be here. Now the first one, we know that x plus y plus that 2 is equals to 15. So you bring the right term together. So it will be x plus y. You take that 2 to the other side. 50 minus that 2. You get 18. You can call it equation number 1. Then, let's be here. Achana notes kabisa. That's why I'm explaining here. We know very well that if you take 45x plus 65y plus 2034. Now that's the total. So how do we get the mean? You see that to get the mean is a summation of fx divided by summation of f. So this is the summation of fx. If you divide by summation of f, how much is the summation of f? Hey, how many students do we have? See, they were 50. How much will be your mean? I put some required. Required, you are told that the values of x are required, the value of x and y, given that the mean distribution is 61.2. So you already given the mean 61.2. I repeat again. I've just taken the summation of fx, which is this. If you divide by the frequency, which is the total number of students, which is 50, you're told that the mean is how much? 61.2. So we want to determine the unknown. So you cross multiply. So if you cross multiply, it will be 45x plus 65y plus 2034 is equals to, you cross multiply 50 times 61.2. You get? You get that 60, eh? You get that 60. Let's bring the right term together. 45x plus 65y is equals to, you take this to the other side. So that's 60 minus 20, that's 4. 10? 10, 26. So you call it equation number 2. So now with that, I can say that using equation 1 and 2. You already have equation 1 where x plus y is equals to 18. You have equation 2 where 45x plus 65y is equals to 1026. So you substitute. So you can multiply by 45, and you can multiply by 1. So let's eliminate x. X times 45, you get 45x. Y times 45, you get 45y. 18 times 45? Yes? 810. That is when you multiply by 1. So it will be 45x plus 65y is equal to 1026. So in minus. Let's take this minus this. 1026 minus 810. Yes? Yes? 216. 65 minus 45? Get 20y. So give me y. Get 10.8. But remember, what we are looking at is the number of students. So this one will be equivalent to 11 students. So already have our y. So y, it will be 11. If y is 11, so how much will be x? X itakuja ngapi? 7 students. X 7 students. And we are done. So of those students who scored between 40 to 50, there were 7 students. Those who scored between 60 to 70, there were 11 students. And they have answered number 1. That's how we get to 8 marks. Yeah, the value of x and y. Number 2, we need the variance. How do we get the variance? Number 2, we need to get the variance. say that how do we get the variance? So to get the variance, we say that you take summation of fx squared divided by summation of f, all of it you multiply minus summation of fx over summation of f, all of it you square. So we need summation of fx squared. So let's compute that. Fx squared. So it will be 2 times 27 squared. What do you get? Get 1450? 1458. 5 times that 5 squared. 61. 25. This will be 7 times 45 squared. 14,175. This one will be 27 to 25. 46, 475. They'll get 45,000. We get 36, 125. It'll get 27,075. And if you add the total, it'll get 203,658. So to get the variance, you take summation of fx squared, which is 203,658. You divide by the summation of frequency, they were 150 students, minus, what is this? Summation of fx over summation of f. That's our mean, right? How much was the mean? Was it 61.2? Yes, then you just square. Yeah, this one you have already been given. This one, summation of fx over summation of f is equivalent to mean, of which you are told that the mean is 61.2. So how much will be the variance? You get? What's that? Yes. Summation of f. Yeah, this one is not 150, should be 50. Yeah, and the number of students was 50. So you already have the solution in your notes. So now last three. First of all, let's look at measure of partition. That one you go through it. Measure of partitions. Hoping you are there. Yeah, and these are measures that subdivide data into equal parts. Yeah, that's what we call partitioning. Yeah? We're back in our notes. And they are named according to the number of parts the data is divided into two. The number is divided into. They can be obtained using an OGIF. So I given the formula on how to get the quantiles. Also, the measure of skewness, I've already given that. And there are 3 types of skewness. I've explained everything there. Normal data or symmetrical curve, negative skewness, all that. Also, I've given the difference between the variance and skewness. That's something you can be able to absorb. Also, characteristic of a good measure of skewness, you go through that. Also, on how to get the Carl Pearson's coefficient of skewness. It's all about cramming those formula. All that. Now, I want us to look at measure of kurtosis. There is something I want to explain there. Measure of kurtosis. Yeah, measure of kurtosis. Now, these are measures used to show the peakness of a set of data. Yeah? Peakness, it's all about the normal curve. We did the normal curve. At normal curve, there was something like this. So now, measure of kurtosis try to describe how peakness is our curve is. And they are classified into 3. Kurtosis give the measure of flatness of the distribution. And the degree of kurtosis of a distribution is measured relative to that of a normal curve. So the normal curve will act now to be our benchmark. And draw it well. So that's our normal curve. Like that. We have some curves which will be much steep like that. And we have another one, which will be below the normal curve. So the kurtosis are classified into three, depending on the peakedness, like that. The curve with a greater peakedness than the normal curve is called leptokurtic. This one is leptokurtic. The one which is sharp. Then the curve which is more flatter than the normal curve is known as bradycardic. This one being our normal, the one which is below the normal curve, you're saying that it's known as bradycardic. What about the normal one? The normal curve is called mesocardic. Normal one is mesocardic. Those are the three kurtoses. The one which is much sharper is leptokurtic. The one which is more flatter than the normal curve is bradycardic. And the one which is equivalent to the normal curve is known as the mesocardic. Yeah, and I think I have explained that using that curve. Now let's go back to our past paper, April 2022. April 2022, question 2. April 2022, question 2. Yeah, question 2A, the question was, that's under April 2022. Question 2. Explain three types of kurtoses that a graphical representation of a frequency distribution can assume. Yeah, not this. So you can even draw using a graph. Now, once you draw using something like this, to explain becomes easier. Mesocardic, one equivalent to normal curve. Lepto, the one which is more sharp than the normal curve. And then bradycardic, the one which is more flatter than the normal curve. As simple as that. Yeah. So, and that marks the end of that topic. As well as that was the last topic. I think now we are done with the entire syllabus of the quantitative analysis.